So, we are going to be looking at Unit 2, Lesson 2. Um, and just to get started looking at it, I'm going to show you a couple words on the screen. And I want you to think of what mathematical operation you think of when you hear these phrases. We got bigger than, older than, higher than. And I bet if I asked you to think of some other everyday phrases, you could pick out ones that have mathematical meanings, because pretty much, not everything, but a lot of what we do every day does have a mathematical meaning behind it, whether we're thinking about it up front or not. So take a second actually and try to come up with a phrase for any operation, addition, subtraction, multiplication, division. And just to kind of guide us into this lesson, I like to look at this this warm-up kind of problem to start thinking about things. So if I asked you to explain what this sentence means: to get to school, Susie walks 5 blocks less than Bill. Can this sentence be written mathematically? Many of you are probably thinking yes. If you knew how many blocks Bill walked to school, how would you figure out how many blocks Susie walked? These are the questions that I'd like you to start getting in your brain as we go through this lesson, because today's lesson is all about writing algebraic expressions. So this is lesson 2 of Unit 2, and the objective, not that you have to write it down, but just to kind of focus what we're doing, is to be able to write algebraic expressions and then to use them to solve problems. And the best way to do this is really just to go through some examples. You'll notice on the My Homework app that I posted an additional resource. I highly recommend printing it out and adding it to your notes, or if you'd rather just kind of write out your own copy, which might take a while. But I'll pull that up on the screen real quick. It looks like this, and it's got some clue words. This thing is a great resource when you're trying to write algebraic expressions. It has a lot of good clue words that tell you what operation we're dealing with. And we'll point out a couple of these as we go, but I would either print this out or pull it up on your screen or write it out. I can even provide you a copy if you don't have a working printer at home, but a great resource to have, so consider using it. So let's get started with our first example. The notes really are purely examples for this lesson. So you'll see the directions say to write the phrase as an expression. So 8 fewer than 21. If you went back to that clue words sheet, and some of you already are thinking this, fewer than, so I'm seeing that right here under subtracting. Okay, fewer than is telling me I'm going to be subtracting. So 8 fewer than 21. Well, I'm starting with 21, and I'm finding 8 fewer than that. And if I was going to take this, this is actually not an algebraic expression. There's no algebra component to this. We're just starting with a basic numerical expression, but 8 fewer than 21, you'd write it out just like this. So you're taking that key phrase in red, figuring out what operation it is, and then putting it all together. It takes practice, and we're just going to be doing a ton of practice with this lesson. This next example here, the product of, hopefully you're thinking already, product means multiply, which means I'm just going to be multiplying these two. The reason I like to pull up this one is as we're writing algebraic, I realize this is not an algebraic expression, but as we do algebraic expressions, don't use x as a multiplication symbol, okay? No more. It's just going to confuse you. You have two options now. You can use this, that tells me multiply, or you can put one or both of your numbers in parentheses, so either like that or like this. This tells me that I'm multiplying. It implies multiplication. So either one of these will work. Do not use the x as a multiplication symbol anymore, especially when you're working with algebraic expressions. You're just going to confuse yourself. You're going to think that that x is a variable when it's really a multiplication symbol, and then things will go awry, so don't do that. Let's look at our next set of example problems, and before we do, actually, I'm going to post a question I'd like you to try. All right, now that you've tried that question, we're just going to practice a few more. So now these are algebraic. Here I've got a variable, and let's put it all together. So 14 more than a number. So I'm going to go back and let's see if we can figure this one out. All right, more than. That's telling me I'm going to be adding. So 14 more than a number, which we're representing with the variable x. So 14 plus x. There we go. Okay. The subtraction ones will be the most challenging for everyone, just because the order will get messed up. For example, what I mean is, in this example A here, I could have written x plus 14 or 14 plus x. They'll mean the same thing. 2 plus 1 is 3, 1 plus 2 is 3. But if this was subtraction, 2 minus 1 and 1 minus 2 mean two completely different things. So when you're dealing with subtraction, you've got to be very careful that you're ordering things properly. So a number y minus 75, that tells me that y minus 75, that's the proper order for that one. A couple that you're going to want to be careful with, we'll look at in more detail in class probably, because I'd like to work through them with you. But when you've got less than or subtracted from, those are two ones that usually that wording kind of messes with people, so we'll look at those in class together. But just make a note to yourself to be very careful when dealing with subtraction, because order matters for subtraction, although it doesn't with addition. Our next example, quotient. Quotient tells you division. Order matters for this one too. If you look back on this clue word sheet, you'll notice in the bottom, I'll circle it here, corner, just a little helpful hint. For multiplication, the coefficient, which if you think back to last night's lesson, the coefficient is the number, the factor that's in front of the variable. So coefficients always come first, but division, the first number that is mentioned is in the numerator, so up top, divided by the second number, which goes down here. All right. So if we go back to our division example, the quotient of 3 divided by a number represented by z. It's important, order does matter. This is your dividend, the number being divided by z, the divisor. So a helpful hint, the first number when you're dealing with division that's mentioned goes on the top, or if you're writing it from side to side, it comes first, divided by the second number. Okay? And just to see it another way. Okay? Quotient tells me that I'm dividing, and then just remember that helpful hint. First number, dividend, second number, divisor. All right, now these for some of you are probably enough as is. It's going to take time to really hone in on this skill of translating words into algebraic expressions, but the real challenge comes in taking it out of a word problem and turning it into an algebraic expression, which is what we're going to look at next as an example. And remember, this is just a starter lesson. We're going to do plenty of practice and work together in class, but let's look at one word problem together before we call it a day. And before we do, actually, let's try a few more example problems on your own. So here's a few. All right, and here's the word problem that we're going to look at. It's going to seem a lot worse than it is, but I promise it's not that bad. I'm going to break it down for you. So we've got the length of Interstate 90, which runs all the way from the west coast to the east coast, is 153.5 miles more than 2 times the length of Interstate 15, which runs from Southern California to northern Montana. If we let m be the length of Interstate 15, can we write an expression to use to represent the length of Interstate 90? So let's break this down because this sounds horribly confusing at first glance. Always start with the question. It's asking us, how can we represent what? The length of Interstate 90. So I'm pulling out a highlighter just to pull this apart. So at the end of the day, I want some expression that tells me how long Interstate 90 is based on this information. Well, if I want to be able to tell how long it is using an algebraic expression, I need to know some details about it. So you need to go back into the problem and try to find information that tells you about Interstate 90. So if I go back up here, well, here we go. Interstate 90 is what? Well, let's pull it apart. It's 153.5 miles more than 2 times the length of Interstate 15. So right there it tells you exactly what we need to know. And it also tells you that m is the length of Interstate 15. So I'm going to rewrite the important information so that we can look at it together. Essentially, what it's asking you to do is write this. 153.5 more than, and I apologize my poor handwriting on this, 2 times m. 153.5 more than 2 times m. I'm taking m and I'm letting that represent the length of Interstate 15. So these two things, I'll change the highlighting color. The length of Interstate 15 and m, that m represents that. So all I'm doing is writing an algebraic expression for 153.5 more than 2 times m, which you can do. It's a whole lot easier than that whole word problem. So let's start with 2 times m. 2m, because when I've got this number right next to this variable, this implies multiplication. So that takes care of this. And 153.5 more than, well, if you go back to your little cheat sheet, your clue words, more than means addition. So plus 153.5. And what was this even telling me? This is the length of Interstate 90. Interstate 90 is, if you take the length of Interstate 15, multiply it by 2, and then add 153.5, that'll give you the length of Interstate 90. I've just taken this whole crazy word problem and represented it with one simple algebraic expression. Now, I might have made that seem a lot easier than it was for you, and that's okay. This is your first time looking at a word problem like this. We're going to be doing tons of these in class together, and I promise it's going to feel a lot easier and you're going to be a lot more comfortable once we do a bunch of these. So I'm going to leave you with one problem to try on your own to end this, and that problem is what we originally looked at. To get to school, Susie walks 5 blocks less than Bill. I would like you to write an algebraic expression to represent the number of blocks that Susie walks if B represents the number of blocks that Bill walks. So use this information to come up with something that tells me how long Susie walks. Susie walks what? Try it on your own. We will talk about it first thing in class tomorrow, and we're going to be doing plenty more examples then. If you have time to print out or make your own clue words sheet, please do. If not, we'll make some in class and we'll go from there. Good luck, do your best, thanks for watching, see you tomorrow.